Hello everyone, welcome to our channel. In this video, we will create a beginner-friendly database design with explanations. In our example, we are building a light version of a database design for a photo sharing app. In the upcoming videos, we will build upon this example and advance the logic further. The very basic definition of a database is that it is a storage area for records that your software needs. You can use either singular or plural names for your tables in your database. On the other hand, during development, accessing singular data from a plural named table, for example user's name, might confuse some people. Ultimately, there isn't a right or wrong choice between singular or plural naming conventions. It's entirely up to the development team or a project architect at the project's outset. In our example, the user is central to the application, so starting with the user table makes sense. We begin by defining column names and explicitly specifying their data types. Define the ID column as an integer, meaning a number, and mark it as a primary key. Let's briefly discuss primary keys and other keys before we continue. A primary key uniquely identifies a record. Let's make the username, name and surname columns nvarchar. We will collect an email and a profile photo from every user. Select the varchar data type for both email and photo URL columns. We do not store the photo itself in the database, just the URL pointing to the photo's location. nvarchar and varchar are both text data types. The main difference is nvarchar supports Unicode characters, allowing it to handle various characters from different languages. We also need to know if a record is active or inactive. Boolean data representing true or false conveys this information. Another important piece of information is the time step indicating when the record was created. We will use the datetime data type for this. We have now completed the design of our user table. Remember, in our example, we are designing a photo sharing app database. We will refer to images as posts. Let's create the table for user posts. Each post needs an ID. It will be the primary key of our post table with an integer data type. Posts are created by users, so we need a relationship between these tables. A foreign key helps us link records across different tables. We will use user ID column as a foreign key. Establishing relationships between tables helps maintain data integrity. Remember, we aim to avoid storing unlinked data. There are three relationship types used to link tables: one-to-many, many-to-many, and one-to-one. If one record in a table can link to multiple records in another table, but each record in the second table links back to only one record in the first table, then you have a one-to-many relationship. If one record in a table can link multiple records in another table and vice versa, then you have a many-to-many relationship. If one record in a table can link to only one record in another table, and the same applies to other way around, then you have a one-to-one relationship. To select the correct relationship type, ask yourself simple questions. In our case, the question is, can any user have more than one post in our application? If the answer is yes, one user can have many posts, establishing a one-to-many relationship. At this point, our scenario doesn't allow a single post to belong to multiple users. We might change this rule in the future. Let's add columns for the title and photo URL. We will store the URL where the photo is located, referring to the photo being posted. We have now completed our post table for the time being. In our app, users will follow other users to see their posts in the feed. Therefore, we need a table to keep follower records. Both the followed and follower are users from our user table. Therefore, we link both followed and follower columns to the primary key of the user table. Let's establish the relationship between the user and follow tables. If a single column isn't sufficient for uniqueness, we can combine multiple columns and use this combination as a unique key, known as a composite key. We rely on uniqueness in our database. We also want users to leave comments on posts from other users. Therefore, we need another table. Let's name it comment. First, we need an ID column serving as the primary key. Then add a column to store the user ID of the commenter. We will use user ID column as a foreign key. Let's establish the relationship between the user and comment tables. A user can leave multiple comments on posts, but the same comment cannot be written by two users simultaneously. Hence, the relationship between user and comment should be one-to-many. Additionally, we must establish a relationship between the comment and post tables. We will use post ID as a foreign key. A post can have multiple comments, but the same comment cannot belong to multiple posts. Therefore, the relationship here should also be one-to-many. Let's store the comment content in a content column. We also want to count the likes a post receives. For this, we create another table to keep track of these likes. Start by defining a primary key. Likes to posts come from users, so we establish a relationship between the user and like tables. Let's add a user ID column and establish this connection. We will use user ID column as a foreign key. A user can like many posts, but a single like cannot be given by multiple users. Therefore, the relationship here is one-to-many. We also need to know which post each like belongs to. We will use post ID as a foreign key. Therefore, we create a relationship between the like and post tables. A post can receive multiple likes, but the same like cannot belong to multiple posts. Again, our relationship is one-to-many. In our starter example, we also want users to send and receive messages. To fulfill this requirement, we need a message table. Start by adding a primary key. We must track the message sender and receiver. Add columns for sender and receiver and establish these connections. Also, add a column for the message content. I want the message sender to know when the receiver reads the message. Therefore, add a boolean column to store this information. It will be true when the message is read. A widely used approach for deleting records from databases is to avoid actual deletion. Instead, we use an isActive column, toggling its value to false to signify deletion. We will also add a column to track the message creation date. We've completed the initial step of our database design. You can optionally configure and define the physical space allocated for table columns. Limiting column sizes is a common practice, especially in large systems. Just keep in mind that you must handle these limitations in your software. If not handled correctly, you might encounter errors when exceeding these limits. Another critical note is specifying mandatory data. You can set columns as required, non-nullable, ensuring this is managed in your software's development phase. Up to this point, we have created a database design for a photo sharing app from scratch. In upcoming videos, we will expand on this database design. Additionally, we will implement the database designed here. That's it. Please don't forget to subscribe to our channel so you won't miss the upcoming videos in this series.